Right, welcome to part one of lecture 4, where we are going to go through process costing, which is chapter 5 in the text. All right, so previously we spoke in last lecture about job costing or job order costing, and the thing that distinguishes job costing from process costing is the nature of the production. So a job is a discrete group of products that are being created. It has a start and an end. It can only be 1 unit long. It can be 1,000,000 units, but there's a first unit and a last unit, and then you move on to the next job, and costs are then tracked in that next and any subsequent jobs. Process costing is designed for production that doesn't really have a start and an end, or has a really, really long runtime. They're basically just continuous flow type stuff. So the best example is perhaps this petrochemical thing here, right? Where uh, you know crude oil comes in at one end, and gas and jet fuel and all that other sort of different stuff comes out the other, and it just keeps going on and on and on and on. Maybe it goes up a bit in 1 month and down in the next month, but it never really stops. So you don't have a first and a last unit. And so instead of a job, we look at it as a continuous process. But because we have to report financially on a regular basis, we assume then that the month is essentially the unit, or the job size, if you will, that we deal with. But bear in mind that on the first day of the month, you will begin with some partially completed units, and at the end of the month, you'll have some partially completed units in your work in process inventory. So this is all about coming up with the average cost, which is really simple. It's all the cost, the total cost that were expended in the month in terms of production, divided by the number of units produced. It gets tricky when you have those partially completed units at the beginning and the end, and you'll see how we deal with that as we move along here. So I've just kind of gone through the differences overall between job costing and process costing. The key here is continuous basis or for long periods, right? So that's why process costing ends up being different. No real change in how materials, labor, and overhead sort of flow in. The processing department is one section, I guess, of the work in process. If there's one department, then it's simple. But often in these processes, they'll go from one department to the next department to the next department, and so on. As you see here in this particular slide, so stuff will happen in the one department, and then when it's finished, the partially completed goods will move to the next department. They'll have some work done on them, and so on. And it's possible even that some more raw materials get added at each section as well, possibly, not always, and so on. And so the key here is we have to do process costing in each separate department to get an overall cost of production for the month, and then what we have left over in our ending work in process inventory. So if you look at T accounts from the flow of the costs, again, raw materials go from the raw materials inventory account into the work in process here of the first department, in this case mixing. That they may also go into the second department if the finishing department consumes raw material as well, and so on. And then that's for the direct material. The indirect material, remember, goes into overhead. This is traced, and the stuff going into overhead is allocated, or to be allocated or applied later. Okay. Same thing with labor. Direct labor into the mixing department and finishing department. Indirect labor goes into overhead to be allocated subsequently. And then eventually the overhead gets applied to each account at the end of the month. You'll do that analysis to allocate those costs out to the individual department. So this isn't the flow of goods. We need to emphasize that. This is the flow of costs, the dollars, how we do the accounting for the process costing. Okay, so as we chug along, what gets interesting or is dealing with the partially completed units. And so um, remember we had back up here, we've got these two departments. We've got the mixing department up here and then the finishing department here. Well, at some point when a product is finished in the mixing department, it moves to the physical product, moves from the one to the next and so on. And the costs will do that as well. So, just at the end of the month, we look at what we have to transfer out of this one work in process department into the next, and then eventually out of the next one and into finished goods and so on. So that's sort of how the flow of costs will happen, and so on, and then ultimately out of finished goods into cost of goods sold once they get sold. Okay, so there's the flow of costs. We're not going to fuss about the journal entries, just like we didn't before in job costing, but we do need to look at some of there are some trickier aspects to costs involved in all of this. And so if you think of the the first department, we're going to add direct materials and some labor and maybe some overhead and so on. But then in the second department, we deal with what we call transferred in costs. And so these are costs that come from an earlier department upstream, and so on. But we can also add in some additional costs as well. So it's, as it says here, costs in the subsequent departments consist of the materials, labor, and overhead in the earlier departments, as well as any costs that get transferred in, and so on. So the way that we look at these product cost categories is generally in two forms. One will be in labor, and the other one in conversion costs. Now, not necessarily. It's possible that we can use more than those two categories, but those are the most common ones that we look at, is direct materials and conversion costs. Conversion costs being labor and manufacturing overhead, as it says here. So for each department, we track two different sets of costs that we will then add together for the total costs in that department. Now, remember we talked a little bit about this idea that you would have some partially completed units at the beginning of the month that were worked on in the previous month. So on the first day of the month, you've got some partly finished units, and same thing at the end of the month, you'll have some partially completed units in each department. So unless the rare instance that the last unit is finished precisely on at 2 minutes to midnight or whenever the heck the thing shuts down on the last day of the month. But generally speaking, you can expect to have these partially completed units, and they're going to be a range, right? If you think of the assembly line as it's just sort of a conveyor belt, and at maybe 1 minute to 5 p.m. on the last day of the month, the bucket of parts opened up and dumps a bunch of direct materials on the conveyor belt, and so that's the least complete unit that you have. All the way right up to the other end of the conveyor belt where you got an almost finished unit for that department. It's just missing one little screw, and that's the last thing to go in, and the guy who's working on that one doesn't quite get to it before quitting time on the last day of the month. So on the first day of the month, the next day, that's the range of your partially completed units. Some of them are totally almost nothing, and some are almost totally complete, and then there's sort of everything in between. But what we do from an accounting perspective is we approximate all of that with a concept called equivalent units of production. And so what we basically say is, look, just to simplify things, we're not going to worry about something that's 1% complete and something that's 99% complete. We're going to get someone in the production end of things, the shift supervisor or whoever, to give us an estimate based on, some whatever kind of science they have in that particular industry, and based on his or her years of experience looking at stuff, and say, okay, of this range of partially completed units, on average, what percent complete are they? So, the easiest example here is to say, look, an equivalent unit is basically, two 1/2 completed products are equivalent to one completed product. So in other words, the as they're stating here, 10,000 units that are on average 70% complete end up being equivalent to 7,000 complete units. And so that's how we estimate the number of units in our work in process inventory at the beginning and the end of every month. We come up with this equivalent unit concept. And the calculation is, it's relatively straightforward. It's not totally simple, but you'll see when we get to the process. But it's important. You really got to get your head around this concept of equivalent units. Otherwise, process costing is going to be a painful mystery to you, and you will just not be happy. So spend the time to think about this. Again, 3 units that are each 1/3 complete are equivalent to 1 unit. Or a unit that's a quarter, another unit that's a half, and another unit that's 3/4 complete are equivalent to 1.5 complete units. It's just kind of doing the math and getting it straight in your mind. Okay, so how do we then calculate the cost for an equivalent unit for the period? Well, we look at the total cost for the period divided by the equivalent units produced in the period, and that gives us this magical number, cost per equivalent unit. Okay, and that allows us to track the costs of our production for our pricing decisions and so on down the road, and for valuing the inventory on our balance sheet as well. Okay, there's 2 broad methods to use in calculating the equivalent units inside of process costing. The simplest method is called the weighted average method. A more complicated but more accurate method is called the FIFO, or first in, first out method. Because this is really designed to teach you guys about the concepts as opposed to the nuts and bolts, we're not going to focus, we're not going to really do the second method. We will just look at the weighted average method. But be aware that there's 2 methods involved here, and I'll explain a little bit what the drawback or the minor inaccuracy of the weighted average method is. Okay, here's how the weighted average method works. It basically says, look, all the units that we have finished producing and transferred into the next department or into finished goods are going to be counted as whole, fully completed units in terms of production in the month. And we then also are going to add to that the equivalent units produced in the month. So it's these two things, what's been transferred out and what's left over in work in process. Okay, so it doesn't line up well, but this is basically work in process, and this is what we finished and transferred out. The drawback here is embedded in this number. What we're assuming is production in the current month is also the beginning work in process. So we're pretending that this month's production includes the partially completed, includes all of the production costs of the partially completed units, even the stuff that was incurred in the previous month. But it doesn't really matter because we're talking about coming up with a cost per equivalent unit. So if this cost number is slightly overstated and the equivalent unit number of production is slightly overstated on the same basis, when you divide them, then it will be very close to the perfect, correct and accurate cost per equivalent unit that you would get from the FIFO method. And if you didn't really follow that, don't worry about it. It's not going to be on the test. Okay, so how do we go about actually doing these calculations? We create something called a process costing production report, and we're going to look at little sections of it as we go here, and then we'll build towards creating the full, complete production report as we work through some of our demo problems, and then as you get into the homework. But that is going to be the thing that you will need to create on an exam or anything like that is the full-on production report. So just bear that in mind. I think we'll launch that in part 2 of the lecture.